first National Electrical Code violation involves overcurrent protection. Number 6 wires cannot be used on a 400 amp circuit breaker. According to National Electrical Code Table 310.15b16, the ampacity of number 6 American wire gauge copper wire is only 90 amps. The second National Electrical Code violation pertains to parallel run terminations. National Electrical Code Article 310.4 states that conductors connected in parallel shall be connected in such a manner that current is equally divided between all conductors. This means that parallel runs should be terminated at a device that ensures equal current distribution, such as a splitter or a busbar. In this case, the parallel runs are terminated in a junction box, which does not provide the means for equal current distribution. As a result, it is possible that one of the number 4/0 conductors may carry more current than the other, which could lead to overloading and overheating. It is always good practice to follow the principle that parallel runs should start and end at a device that ensures equal current distribution. In this case, the ideal solution would be to install a busbar or a splitter at the termination point of the parallel runs and then connect the number 6 wires to the appropriate fuse disconnects. This would ensure that the current is evenly distributed among all conductors and that the fuse disconnects are properly protected. When installing electrical systems, it's critical to adhere to the National Electrical Code to ensure safety and prevent potential hazards. Overcurrent protection is a fundamental aspect of electrical safety. It is designed to protect conductors and equipment from excessive current, which can cause overheating, insulation damage, and even fires. Circuit breakers and fuses are the most common overcurrent protection devices. They are designed to interrupt the flow of current when it exceeds a predetermined level. The ampacity of a conductor is the maximum amount of current that it can safely carry without exceeding its temperature rating. National Electrical Code Table 310.15b16 provides ampacity ratings for various types of conductors based on their size, insulation type, and installation conditions. Using a conductor with an ampacity lower than the overcurrent protection device rating is a code violation and can create a significant safety hazard. In the described scenario, the use of number 6 American wire gauge wires on a 400 amp circuit breaker is a clear violation because number 6 American wire gauge copper wire has an ampacity of only 90 amps as per National Electrical Code Table 310.15b16. This means that the number 6 American wire gauge wires are not capable of safely carrying 400 amps of current and are at risk of overheating and failing, potentially leading to a fire. Parallel conductors are used when the required current carrying capacity exceeds the ampacity of a single conductor. When conductors are connected in parallel, they must be of the same material, size, insulation type, and termination method. This ensures that the current is equally divided among the conductors. National Electrical Code Article 310.10h outlines the requirements for paralleling conductors. It states that conductors shall be the same length conductor material, circular mill area, and insulation type. Additionally, all parallel conductors must terminate in the same manner. The purpose of these requirements is to ensure that the impedance of each parallel conductor is as close as possible, promoting equal current sharing. When parallel conductors are terminated in a junction box without any means of ensuring equal current distribution, it is possible for one conductor to carry more current than the other. This can lead to overloading of the overcurrent conductor, causing it to overheat and potentially fail. In the described scenario, the parallel runs of number 4/0 conductors are terminated in a junction box, which does not provide any means for equal current distribution. This is a violation of National Electrical Code Article 310.10h, which requires that parallel conductors be connected in such a manner that the current is equally divided among them. A busbar or a splitter is a device that can be used to ensure equal current distribution among parallel conductors. A busbar is a conductive bar that is used to distribute electrical power. It provides a common connection point for multiple conductors, ensuring that the current is evenly distributed among them. A splitter is a device that divides a single input current into multiple output currents. It is designed to ensure that each output current is equal to the others. By installing a busbar or a splitter at the termination point of the parallel runs, it is possible to ensure that the current is evenly distributed among all conductors. This will prevent overloading of the overcurrent conductor and ensure the safe and reliable operation of the electrical system. In summary, the described electrical installation has two National Electrical Code violations: the use of number 6 American wire gauge wires on a 400 amp circuit breaker and the termination of parallel runs in a junction box without any means of ensuring equal current distribution. To correct these violations, the number 6 American wire gauge wires should be replaced with conductors that have an ampacity of at least 400 amps. And a busbar or a splitter should be installed at the termination point of the parallel runs to ensure equal current distribution. Always consult the latest edition of the National Electrical Code and seek the advice of a qualified electrician to ensure that electrical installations are safe and compliant. The National Electrical Code, or National Fire Protection Association 7T, is a regionally adoptable standard for the safe installation of electrical wiring and equipment in the United States. It is part of the National Fire Code series published by the National Fire Protection Association, or NFPA. While the National Electrical Code is not itself a United States law, it is commonly mandated by state or local law. The National Electrical Code is updated every 3 years. The purpose of the National Electrical Code is to protect people and property from hazards arising from the use of electricity. It covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The National Electrical Code is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical work. Articles provide more detailed information on specific topics within a chapter. Sections provide specific requirements for electrical installations. The National Electrical Code is a complex document, and it is important to have a thorough understanding of its requirements before attempting any electrical work. It is always best to consult with a qualified electrician if you have any questions or concerns about the National Electrical Code. Grounding is another essential aspect of electrical safety. It provides a path for fault current to flow back to the source, tripping the overcurrent protection device and preventing electrical shock. The National Electrical Code outlines specific requirements for grounding electrical systems, including the size and type of grounding conductors, the location of grounding electrodes, and the methods for bonding metal enclosures. Proper grounding is critical to ensuring the safety of electrical systems and protecting people from electrical hazards. Electrical installations must also comply with the National Electrical Code requirements for wiring methods. Wiring methods refer to the way that electrical conductors are installed and protected. The National Electrical Code specifies different wiring methods for different applications based on factors such as the environment, the voltage, and the ampacity of the conductors. Common wiring methods include conduit, cable, and surface raceway. Each wiring method has its own set of requirements for installation, support, and protection. The National Electrical Code also addresses the installation of electrical equipment such as lighting fixtures, receptacles, and appliances. It specifies requirements for the location, mounting, and wiring of equipment to ensure that it is installed safely and correctly. The National Electrical Code also covers the installation of special equipment such as generators, transformers, and fire alarm systems. These types of equipment have unique requirements that must be followed to ensure their safe and reliable operation. In addition to the National Electrical Code, there may be other local codes and regulations that apply to electrical installations. It is important to check with the local authorities to determine which codes and regulations are in effect in your area. Compliance with all applicable codes and regulations is essential to ensuring the safety and legality of electrical installations. In conclusion, the National Electrical Code is a comprehensive standard for the safe installation of electrical wiring and equipment. It covers a wide range of electrical topics, including overcurrent protection, grounding, wiring methods, and equipment installation. Compliance with the National Electrical Code is essential to protecting people and property from hazards arising from the use of electricity. The National Electrical Code is a living document that is constantly updated to reflect new technologies and best practices. It is important to stay up to date in the latest edition of the National Electrical Code to ensure that your electrical installations are safe and compliant. When in doubt, always consult with a qualified electrician who has the knowledge and experience to ensure that your electrical work is done safely and correctly. Understanding the National Electrical Code's requirements for parallel conductors is essential for electrical safety and ensuring proper current distribution. The code specifies that parallel conductors must be of the same length, conductor material, circular mill area, and insulation type. This uniformity is crucial for maintaining equal impedance among the conductors, which in turn ensures that the current is evenly distributed. Terminating parallel conductors in a manner that doesn't guarantee equal current sharing can lead to one conductor carrying more current than its capacity allows. This can cause overheating, insulation damage, and potentially lead to electrical fires. The National Electrical Code emphasizes the importance of using devices like busbars or splitters to ensure equal current distribution among parallel conductors. These devices provide a common connection point, allowing the current to flow evenly through each conductor. In this specific scenario, the use of number 6 American wire gauge wires on a 400 amp circuit is a clear violation of the National Electrical Code due to the ampacity limitations of the wire. Furthermore, terminating parallel runs in a junction box without any mechanism for equal current distribution is also a violation. To rectify these issues, it's essential to replace the number 6 American wire gauge wires with conductors that have an ampacity suitable for the 400 amp circuit. Additionally, installing a busbar or a splitter at the termination point of the parallel runs will ensure that the current is evenly distributed among all conductors, complying with the National Electrical Code requirements. Electrical work should always be performed by qualified electricians who are knowledgeable about the National Electrical Code and local regulations. This ensures that the electrical systems are installed safely and correctly, protecting people and property from potential electrical hazards. Staying informed about the latest updates to the National Electrical Code is also crucial, as it helps electricians and installers stay up to date with the best practices and safety standards in the industry.